Hey guys, welcome back to another round of chemistry notes. In this video, we are going to continue talking about our chemical equations, and we are going to practice predicting the products of our reactions. So doing it by type, if you're looking at a synthesis reaction, we can predict the product if the reactants are two elements. For example, magnesium and nitrogen. That's the only time you'll be asked to predict the products of a synthesis is if you have two elements. Flipped on its head, if you are not starting with two elements and you're being asked to predict the products, it's probably not a synthesis reaction. So here we've got magnesium and we've got nitrogen. When these come together, they're going to form an ionic compound, right? Because magnesium is a metal, nitrogen is a nonmetal. So when that happens, magnesium will form the magnesium ion, Mg2+, and nitrogen will form the nitrogen ion, N3-. We're going to need 3 magnesiums and 2 nitrogens to make their charges cancel, so that'll give us Mg3N2. Now we need to balance this. So here on the left, we've got magnesium and nitrogen. On the right, we have magnesium and nitrogen. So we have 1 magnesium and 2 nitrogens on the left. We have 3 magnesiums and 2 nitrogens in our products. So if we put a 3 in front of our magnesium here in the reactants, that'll give us 3 and 3, 2 and 2, and we are all set. We can put a 1 here and a 1 here if we are so inclined, but we do not have to. And that's our balanced equation. So really the same thing we've been doing, just with like 1 step added in front. So that's synthesis. You will only be asked to predict synthesis products if you have 2 elements to start with. Decomposition, pretty much the exact same, just the opposite. We can predict the products if the reactants break apart into 2 elements. So here we've got H2O. It's compound. Literally the only thing it can do is fall apart because it has nothing to react with. And since we're being asked to predict the products, we know it's got to break apart into elements, namely hydrogen and oxygen. Hopefully this looks wrong to you. It should. Hydrogen is diatomic, so this should be H2. And oxygen is diatomic, it should be O2. And then once again, we should balance. So we have H and O, H and O. Here we have 2 hydrogens and 1 oxygen. Here we have 2 and 2. So if we put a 2 here, that'll bring us up to 4 hydrogens and 2 oxygens. If we put a 2 over here in our products, that'll bring us up to 4 hydrogens, and our oxygens remain at 2. So that's our balanced equation there. All right, so decomposition and synthesis, pretty straightforward. There's really only one thing that can happen. Looking at our third type, single replacement, we can predict the products if we know the charge on the new ion. This is only going to happen for ionic compounds. So something that was an ion will be kicked out to form an element, an atom, and something that was an atom will be forming an ion. We can only predict our products if we know the charge on that new ion. So here we've got silver is off by itself and copper is in this compound. So since we're being told here it's a single replacement, we know silver is going to come in, it's going to kick out this copper, the copper is going to go somewhere else to just be copper metal. So we'll get copper all on its own, that's easy enough. And then we will have silver over here hanging out with nitrate. So a really common reaction that people have to this is that they will try to just straight up replace where it says Cu, they'll just take those letters out and replace them with Ag and try to do one of these. This too is here because of this copper. we needed 2 nitrates because we had copper here. Copper is gone. This 2 is not a given. So when you are doing this, you need to kind of start from scratch. We know that we have nitrate, which is NO3 minus. We know that we have silver, which is one of those tricky ones that I asked you to just memorize. Silver has a +1 charge. So when silver and nitrate get together, we're just going to need 1 of each, and that'll be AgNO3. The 2 is gone because we don't need it. So let's put these over here as our products. Cu and AgNO3. And then let's erase our scratch work here so we can go ahead and balance this. Over here on the left, we have copper and nitrate, which is still nitrate when we're done, so we can leave it as nitrate to balance, and silver. Over on the right, we have copper and nitrate and silver. On the left, we have 1 copper, 2 nitrates, 1 silver. In our products, 1 copper, 1 nitrate, 1 silver. So the only problem here is nitrate. If we put a 2 right here, that'll give us 2 nitrates in our products. It'll also give us 2 silvers in our products, but that is easy enough to fix by putting a 2 here in front of silver in the reactants. So I'm cleaning this up a little bit so it's a little easier to read. There we go. 1 mole of copper 2 nitrate reacts with 2 moles of silver to produce 1 mole of copper and 2 moles of silver nitrate. We're just applying all the same rules we already know in a slightly different way. Not a whole lot new here. Our next reaction to talk about is a double replacement. We can always predict the products on a double replacement because everything's already an ion. We're just kind of scrambling things up and putting them back together. So here, since we have 2 compounds that we are working with, we have copper here and silver here are just going to trade places. They're going to trade partners. Again, you're going to want to split these up into ions and then put them back together. Don't just switch the letters and hope for the best. So when silver comes over here, it'll form the silver ion, that's Ag+, and it's going to be paired up with this nitrate, which is NO3-, like we saw earlier. And now we'll have copper over here. We'll leave the charge for a second, and it's going to be paired up with carbonate, which is CO3, 2-. We need the charge on the copper, which we have, because, as we saw over here, we needed 2 nitrates to cancel out the charge of our copper. So this has been a while since we've done this, but we know that we have 1 copper with a charge of something, plus 2 nitrates. Each nitrate has a charge of -1, and when they come together, they are going to equal 0. So that means that x minus 2 is equal to 0. That means that x is equal to 2, meaning that the charge on copper is 2+. This is our Cu 2+ ion. So then when silver and nitrate get together, that'll just be AgNO3. We just need 1 of each. When copper and carbonate get together, that'll just be CuCO3. We just need 1 of each. We can write those in as our products. Leave a space for a coefficient, and then AgNO3. And leaving a space for a coefficient, CuCO3. So that's our unbalanced equation. We can clear out some of the scratch work, give ourselves room to balance. And again, since it's a double replacement, all of our polyatomic ions are staying polyatomic ions. We can leave them as ions when we balance. It'll be easier that way. So we have copper and nitrate and silver and carbonate. And over here, copper, nitrate, silver, and carbonate. So on our reactant side, that's 1 copper, 2 nitrates, 2 silvers, and 1 carbonate. On our product side, we have 1 copper, 1 nitrate, 1 silver, and 1 carbonate. So copper and carbonate are all good. The only issues are silver and nitrate. And if we put a 2 here on our product side, that'll give us 2 silvers and 2 nitrates, which is what we have on our reactant side. So that's all we needed to do to balance. We have 1 mole of copper 2 nitrate reacting with 1 mole of silver carbonate to produce 2 moles of silver nitrate and 1 mole of copper 2 carbonate in a double replacement reaction. All right, our last type of reaction is combustion, and we can always predict the products because they are always the exact same thing. This one's really easy. Combustion always has products of carbon dioxide and water. All we have to do is balance this. So we've got carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. Over on our reactant side, we have 6 and 12 and 2. Over on our product side, we have 1 and 2, and don't forget to add our oxygens together. 2 plus 1 is 3. This is not close to balanced. Remember, we want to go in the order of carbon, and then hydrogen, and then oxygen. So fixing carbon first, we can put a 6 here on the product side to give us up to 6 carbons. That'll give us 6 times 2 is 12, plus 1 is 13 oxygens. Moving on to hydrogen, we have 12 in our reactants and only 2 in our products. If we put a 6 here as well, that'll give us 6 times 2 is 12 hydrogens. And now we've got 6 times 2 is 12 plus 6 is 18 oxygens. 12 plus 6 equals 18 oxygens. So we have 18 oxygens in our products, 2 oxygens in our reactants. If we put a 9 here in our reactants, that'll bring us up to 18. Now we've got 6 and 6, 12 and 12, 18 and 18, and that is balanced. A little grosser, but practice makes perfect. All right, a couple more examples where we are not told the type of reaction, and then you'll be on your own. So here we've got sodium reacting with iron 3 bromide. A couple of things we can say right off the bat. It's not combustion. If we were given the other half of this equation, it's entirely possible it could be a synthesis or a decomposition. It'd be weird, but it's possible. However, you will not be asked to solve a problem like that. If you're not given one thing falling apart, it's not decomposition. And if you're not being given 2 elements coming together, it's not synthesis. So once again, we've got it down to one of our replacements, either single or double. And since we've got this single element right here, we know it's not a double replacement. We know it's a single replacement. So we know that sodium is going to come in. It's going to kick out the iron. Metals kick out metals. Non-metals kick out non-metals. So sodium will come in and kick out this iron, and the iron will go be iron by itself. So that means that we will have sodium paired with bromine, and we'll have iron all alone. When sodium pairs up with bromine, it'll form the sodium atom, which is +1. And bromine, the atom is 1 minus. So when they come together, we'll need one of each to form NaBr, and iron is just iron. So our products will leave a space, and we have NaBr, and leave a space, iron. So now that we've got our products figured out, we can go ahead and balance this equation. We've got sodium and iron and bromine. on the left, sodium, iron, bromine on the right. Here in our reactants, we've got 1 and 1 and 3. Oops. Here in our products, we have 1 and 1 and 1. So we'll put a 3 here in front of sodium bromide. That'll bring us up to 3 bromines and 3 sodiums. So then we can fix that by putting a 3 over here in our reactants. Bring us up to 3. And that'll be balanced. 3 moles of sodium react with 1 mole of iron 3 bromide to produce 3 moles of sodium bromide and 1 mole of iron metal. Same thing we've been building on, just again, gotta do a little bit of extra work in there. All right, on to our next one. Here we have C2H4O2 plus O2. Again, this one should be pretty straightforward. It's not going to be decomposition because we're starting with more than one thing, and you will not be asked to predict the products for reactions like that. We know it's not synthesis because we're not starting with 2 elements, and you will not be asked to predict the products of problems like that. It's not a double replacement because we've got this element out by itself. It could maybe on very first glance be a single replacement because we have this element out by itself, but what really makes more sense is for it to be combustion. We've got a hydrocarbon reacting with oxygen. It's going to be combustion, and our products are going to be CO2 and H2O. This is combustion. So now we can balance it. We've got carbon and hydrogen and oxygen, carbon, hydrogen, and oxygen. Here in our reactants, we've got 2 and 4, and don't forget to add 2 plus 2 is 4 oxygens over here. In our products, we've got 1 and 2, and don't forget to add 2 plus 1 is 3. And nothing is balanced. This will be fun. Remember to go in order, carbon, hydrogen, and then oxygen. So we need more carbon in our products. We'll put a 2 in front of our CO2, give us 2 carbons. But that's also going to mess with our oxygen. Now we have 2 times 2 is 4, plus 1 is 5 oxygens. But carbon's done, so that, that's good. Next we can look at hydrogen, which is going to be 4 on the left and 2 on the right. So if we put a 2 here in our products, that'll bring us up to 4 hydrogens. And 2 times 2 is 4, plus 2 is 6 oxygens. So last but not least, now we've got oxygen to deal with. On first glance, if you're just looking at these numbers, this looks a little problematic, the 4 and the 6. But our oxygen is split up in the reactants. If we put a 2 right here, that'll give us 2 times 2 is 4 plus these 2, that is 6. So we've got 2, 4, 6, 2, 4, 6. And that's balanced, and this is a 1 here. All right, one more example together before y'all get to practice on your own. Number 3 here, we have NaOH, sodium hydroxide, reacts with H2SO4, sulfuric acid. It's not combustion. It's not decomposition. It's not synthesis. And there are no single elements hanging out, so it's not a single replacement. It's got to be double replacement. These are arguably the most amount of work to get the products, but it's nothing you haven't done before. So we've got sodium here is going to trade places. This is, I guess, a little weird. It's going to trade places with hydrogen because remember, hydrogen can form that H plus ion. So our cations, our positive ions, are going to trade places, trade partners, and we will get our positive hydrogen ion over here paired up with that hydroxide, OH minus. Here we'll get that sodium ion, which remember is Na+, pairing up with that sulfate ion, which is SO4, 2-. And now we write our formulas. If we have a single positive and a single negative over here, that means we just need one of each, and we can put those together as HOH, which you may notice is the same as H2O. And then on the right, we have one positive from sodium and 2 negatives from sulfate. Means we're going to need 2 sodiums to make this cancel. So that'll be Na2SO4. So these are our products. I'm going to leave water written like this because it'll make it easier to balance if we can actually see that hydroxide. So leaving a space, we've got HOH plus, leave a space, Na2SO4. And then we can get rid of our scratch work so there's room to balance. All right, so here we've got sodium. Since hydroxide stays as hydroxide, we can leave it as hydroxide. That hydrogen ion and sulfate. And then over here, sodium, hydroxide, hydrogen, and sulfate. All right, so we have 1 sodium, 1 hydroxide, 2 hydrogens, and 1 sulfate. Here it's 2 and 1 and 1 and 1. All right, so let's just go down the list. Sodium is not balanced. We need more sodium in the reactants. So we can put a 2 here. That'll give us 2 sodiums. And it'll also change our hydroxide to be 2 hydroxides. Let's fix what we broke. That means that we need to put a 2 over here in our products to bring hydroxide back up to 2. That'll also change hydrogen to be 2, which we wanted it to be. We had 2 hydrogens in our reactants. And then sulfate is 1 and 1. So that is balanced. We have 2 moles of sodium hydroxide reacting with 1 mole of sulfuric acid to produce 2 moles of water and 1 mole of sodium sulfate. And if it just really bugs you, it kind of bugs me. We can replace this, HOH, change it back to good old H2O. All right, couple of things I've said many times, I'm going to say them again. You will only predict the products for decompositions that end with 2 elements and that start with one thing. If it didn't start with one thing, it's not a decomposition. If it did start with one thing, it's going to end with 2 elements. Your decompositions you'll be asked to predict are very simple. Same with your syntheses. You will only be asked to predict products if it starts with 2 elements. If it didn't start with 2 elements, you're not being asked to predict the products of a synthesis. It's something else. All right, so now you've got some practice. You have 9 practice problems in your book. Go through, identify the type of reaction, write the products, identify the type of reaction, predict the products, balance the equation. Pause the video while you work. When you're ready to check your answers, go ahead and unpause. All right, hopefully this is what you got for your answers. If not, go back, go through, see if you can see where you went wrong. If I had to guess, you probably forgot to look at the charges and just flip-flopped some letters and called it a day. It's a really common mistake, but it's one I need you not to make. If you did well, awesome, nice job. We have one more thing to talk about in our chemical formulas before we move on to something completely different. So if you're ready, move on to that. Otherwise, go back, get a little more practice. In any case, as always, good luck and happy studying.